In this lesson, we will multiply matrices. When we added and subtracted matrices, we needed them to have the exact same order. It's different when we multiply matrices. We need the number of columns of the first one to be equal to the number of rows in the second one. So that means sometimes you can multiply A times B, but you can't multiply B times A. For instance, if A is a 3 by 2 and B is a 2 by 4, the columns of A and the rows of B need to match up. So notice the 2 matches with the 2. The resulting matrix is going to be 3 by 4. 3 by 4. But if I do those same two matrices in the opposite order, 4 and 3 do not match up, and therefore we cannot find B times A. So it's important that you first find the order of the matrices before you try to multiply them. So let's look at one product together. And this one, obviously, I have all written out for you already. Typically, I don't do that, but I wanted to give you sort of a framework to look back on. So the first thing I would do is I would say this is a 3 by 2 matrix, and this is a 2 by 2 matrix. And therefore, yes, we can multiply them, and the result will be 3 by 2. So typically what I would do then is I would give myself some spaces that are in a 3 by 2 to remind myself that that's what I'm going to end up with. Then what we're going to do is we're going to take each of my rows and I'm going to multiply that by the column. So I'm going to take row 1 times column 1, and that's going to go in row 1, column 1 in my new matrix. So in order to be able to do that, I'm going to think of taking -1, 3 and dropping it down this direction. So this is -1, 3 times all of this. So in this first row, first column, I'm taking row 1 times column 1. So -1 times 5 plus 3 times 6. -1 times 5 plus 3 times 6. So I'm taking this row, turning it into a column, and then I'm multiplying row 1 by column 1. That goes here. This would then be obviously row 1, column 2. So I'm taking my row 1 of my first matrix times column 2. So again, I'm taking -1 times -3 plus 3 times 8. Those values then, of course, I can simplify to get 13 and 27. Then I do the same thing with my second row. I would turn this into a 3, 5. I would take 3 times 5 and 5 times 6. And that's going to go here in my second row, first column. And then I would multiply that second row times the second column. So let's take a look at one that we actually have to do ourselves. This one's going to be a little bit crazy. There's a lot of values going on. But this is a 3 by 3 matrix, and this is a 3 by 2 matrix. So I can multiply them, and my result is going to be 3 by 2. 3 by 2. So typically what I'll do is I'll go ahead and write spaces for a 3 by 2 matrix. Then I'm going to take my first row and I'm going to write it this way. So I'm going to take my first row and write it sort of as a column. So I'm going to take 1 times -6, which is -6, plus 2 times -3, which is -6, plus 3 times 1, which is 3. So I've taken that first row times the first column, and then I'm going to take that first row times the second column. 1 times 5 is 5, plus 2 times 4 is 8, plus 3 times -2 is -6. Now that I've used my first row, then I'm going to look at my second row. So notice now I'm going to be writing in my second row using my second row of 4, 5, 6. So 4 times -6 is -24, plus 5 times -15, or 5 times -3, which is -15, plus 6 times 1. And then I'm going to do the same thing with the second column. So 4 times 5 plus 5 times 4 plus 6 times negative 2. And then, of course, I'm going to do the same with my last row, 7, 8, 9. So negative 6 times 7, 8 times negative 3, and 9 times 1. And then my last one, 7 times 5, 8 times 4, and 9 times negative 2. My resulting matrix is whatever I have when I simplify each of those expressions. And that is my solution. That is the product of the two matrices. This one gives me matrix A and asks me to find A squared. So what many students typically do is they will square and say 16 and 1 and 9 and 0, and this is not correct. So just the same way that if I had x plus 2 quantity squared, I would have to write that as x plus 2 times x plus 2 and FOIL it out. Same exact thing happens here. So if I'm finding A squared, that means 4, 1, negative 3, 0 times 4, 1, negative 3, 0. Again, this is a 2 by 2, and this is a 2 by 2, so I can multiply them, and the result will be a 2 by 2. So not a bad idea to leave yourself a 2 by 2 spaces. I'm going to take 4, 1, turn it into a column and multiply, so 4 times 4 is 16, plus 1 times negative 3 is negative 3. Take it times the second column, which is 4 plus 0. And then I'm going to use negative 3 and 0 and do the same. So negative 3 times 4, which is negative 12. And then negative 3 times 1, which is negative 3. And then my resulting solution is 13, 4, negative 12, negative 3. So you do have to write it out twice and multiply it. Here are 3 questions for you to try, so try all 3 and then press play to check your work. First, let's look at A. Determine that's a 2 by 2. B is a 2 by 3. And C is a 3 by 1. So it's important to know those ahead of time. Can I take A times B? That would be a 2 by 2 and a 2 by 3. Those 2's match up, which means yes, I can, and my result will be a 2 by 3 matrix. So it's up to you kind of how much work you want to show, but I'm going to go ahead and write my 2 by 3. Which means I'm taking A and turning that into a column and multiplying. So that's 6 plus negative 30. That's 10 plus 0, and that's 8 plus 40. Then I'm going to take my 1, 0 and do the same thing. So that's 3 plus 0, that's 5 plus 0, and that's 4 plus 0. And my result then is 6 plus negative 30, which is 24, negative 24, 10, 48, 3, 5, 0. So that's AB. BC is 2 by 3 and a 3 by 1. So 3's match up, which means my result is a 2 by 1. 2 rows, 1 column. So I'm going to take 3, 5, 4 and write it this way. So that's 3 plus 0 plus 24. And then I do the same thing with 6, 0, 8. So that's 6 plus 0 plus 48. And then of course I'm just going to simplify each of those. That gives me 27 on the top. And that's a 0, I think, so that's 54. And last but not least, A times C. A is a 2 by 2 and C is a 3 by 1. These two do not match up, and therefore this is not possible. So only if the columns of the first match the rows of the second.